Hey, it's Miss Phillips, and tonight we're going to be talking about theorems for transversal angle relationships. I know, that's a mouthful. We're going to start working on justifying why we're making decisions that we're making. So, for instance, if I tell you that I know that angle 2 and 3 are congruent, then you can tell me that that's because they're vertical angles, and that's the definition of a vertical angle, that they are congruent. So we're going to start working on that because we're really going to start pushing proofs soon, so I want you to get used to justifying the reasons why you're doing things. So let's go ahead and get started. Basically all these are theorems or postulates that are proving that one thing is either congruent, that one angle is either congruent or supplementary to another. So, and they're basically like the definitions that we did the other day, so I think they'll be really familiar to you. Alright, the first one is the corresponding angle postulate, and it states that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So remember, we said that corresponding meant that they're in the same position on the parallel lines where the transversal meets them. So for instance, angle 7 would be congruent to angle 3. And on this video, it actually goes through and it tells you which angles are congruent. Excuse me, it says that angle 1 is congruent to angle 5. 2 and 6 are congruent because they're both on the top right side. 3 and 7 are congruent because they're on the bottom left. And 4 and 8 are congruent because they're on the bottom right. Okay, the next one is alternate interior angles. And it says if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Now, think about this. You know that a conditional statement has to have an if and a then section, a hypothesis and a conclusion, for it to be a conditional statement. So each of these are conditional statements. Now, let's think about that. Alternate means opposite sides of the line or the transversal, and interior means they're going to be inside the parallel lines. So that would be 3 and 6 and 4 and 5. I hope that's what you were guessing, or knowing, not guessing would be better. Alright, okay, let's go to the next one. I'm glad to say that this video shouldn't be near as long as the last one. Alright, the next one is same side interior angles, also called consecutive interior. That's what I normally call them, because same side sounds way too easy for you. Alright, it says if two parallel lines are cut by a transversal, that's my hypothesis, then consecutive or same side interior angles are supplementary. So same side inside the lines would be, go ahead and tell me, 3 and 5 and 4 and 6. And as we mentioned earlier, consecutive of any kind is always going to be supplementary. So maybe that'll help you. Okay, let me move up a little bit. Okay, now you may have to kind of go back and forth to see the lines. The next set is same side exterior angle theorem. And it says if two parallel lines are cut by a transversal, that's my hypothesis again, then same side exterior angles are supplementary. Alright, again, if they're on the same side, they're going to be supplementary, okay? Unless they're corresponding. Any other time, they're going to be supplementary. So if they're on the exterior, you know that's outside the parallel lines. So hopefully you're guessing 1 and 7 or 2 and 8 should go together. So hopefully I remembered those. Yep. 1 and 7 and 2 and 8. And again, they're supplementary. Don't forget that. Alright, next one. I think there's maybe only one more after this one. It's alternate exterior angle theorem. And it says if two parallel lines are cut by a transversal, my hypothesis again, then the conclusion says then alternate exterior angles are congruent. Okay, so remember, alternate means opposite sides of the transversal, Exterior means on the outside of the line. So let's go back up here and look for a minute. Okay, so opposite outside would be 2 and 7 or 1 and 8. Okay. So again, they've got 2 and 7 and 1 and 8. Alright, the last thing that's on here is actually what they call the perpendicular transversal theorem. And if any of them make sense, it should be this one, I believe. It says, if a line is perpendicular to one of the two parallel lines, then it is perpendicular to the second line. So basically that's saying if you've got parallel lines right here, and you've got a transversal going perpendicular to one of them, then it has to be perpendicular to the other one. That only makes sense. So, unfortunately, I don't have that on here. Oh, but you know what? I could probably make one really quick. Let's see how my skills are. Probably not all that great. Yeah. Okay. Thank goodness for smartboard products. Okay. So here is my perpendicular transversal, and if you'll notice, it's perpendicular to this one, and if it's perpendicular to this parallel line, then it has to be perpendicular to that parallel line. Alright, I think that's about it. I hope you have a great evening,